I guess we're good to go there. All right. Good afternoon. Just a fair warning. I don't know anything about hybrid SQL. I have no clue what it is. Okay, I was substituted. The guy who was actually doing that presentation on hybrid SQL, he fell sick or fell ill. So they asked me like, "Oh, can you do a session to fill up space?" And this session is going to be about analytic functions, and that's Oracle database development. So this is again a fair warning. If you're not into database development, not into SQL, then this session is not for you. All right. So there are other sessions that you might want to go to. Okay. So it is a fair warning, but I'm going to start anyway. So if you're staying, well, welcome in that case. All right. So analytic functions. It's all about SQL. It's all about SQL. I'm Alex. I'm from the Netherlands, so that's why I have this accent. I'm one of the Oracle ACE directors for database development. I'm very proud of it. I tweet, I blog, I wrote a book about Apex. And even though I said I'm never going to write a book again, they tricked me into writing yet another book. All right. Analytic functions are like, they're awesome. They're the best thing ever. I kind of love them. Yeah, yeah, I love them. There's Connor McDonald. He's half of the Ask Tom answering team, and he wrote a video series on analytic functions. So if you want to learn more about it and you feel like, well, this is awesome stuff, check out the video series as well. Short 5-10 minute videos, really excellent. So it's Oracle, or the analytic functions are not. It's not a new thing. So it's not like they were introduced in Oracle 12. They weren't even introduced in 11 or 10. Even 9 already had them. All right. So they were introduced in Oracle 8. So that's real old stuff. To be more specific, they were introduced in 8.16, the Enterprise Edition. So when was Oracle 8.16, the Enterprise Edition, released? This is the time where you get to call out, basically. 90 something. Yeah, 90 something. 1999, to be more exact. So it's old stuff. You could say, well, it's not the latest and the greatest. It is the greatest. It is. It's not the latest. It is the greatest. It's awesome. Tom Kite said about analytic functions, it's the best thing since the select statement. Absolutely true. I love them. So, quick question: who have used analytic functions? So, what are you doing here? Oh, well, yeah, okay. So, if I make a mistake, just shout out where I'm wrong. All right. What am I going to do? It's like more introduction to analytic functions. It turns out that a lot of people still don't use them, even though they're the most awesome thing ever. So we're going to cover the syntax. I'm going to show you some examples. I'm going to point out where the caveats are. I'm going to show you I'm going to tell you the story how I first started using analytic functions, and well, that's about it. So what can you use analytic functions for? Basically for all kinds of ranking stuff, or like ranging averages and that kind of awesome things. All right. So that's like the niche statistical analysis. You can do that as well. Have you ever had that question from like an end user where they say, "Oh, could you dump this table data into an Excel?" Have you ever had that? No. And then they start working on this Excel. This is the M table. Everybody would recognize that, I assume. But then they start working on this Excel sheet and they start adding columns to it, like a running total or a running total per department or a sequence number per department. And they start manipulating it and they're working on this data for a couple of days. And if they would just tell you what they wanted in the first place, you could write a SQL statement to do exactly the same thing, right? With your running total, your departmental total, your sequence number over there. So if you're all database designers, then you comfortable with it, then you would get out your notepad and you start writing a query. You could end up with something like this. There's your running total, there's your departmental total, your sequence number per department, and you have everything you need. This query it's quite a big query, 23 lines of code. Okay, and it's pretty hard to understand. At least I think so. Okay. And one of the other things is it accesses the emp table. That's the one we're using in ISTA. It accesses it 4 times. So you can imagine, like, well, emp is only a real small table, only has 14 rows in it. So this one is pretty fast, no problem. But if your table is really big or bulky, then this might not be the fastest in the world. Had you learned about analytic functions, you could also write a query like this one, where you have your running total, your departmental total, your sequence number, all in one go, accessing the emp table only once. Okay? So you all decided to stay? Good. So these analytic functions, what's it all about? Well, we have to start with all the functions. There are some of the aggregate functions out there, like the count, min, max, those. You know what they do. They're the regular aggregates where you get like a set of data and reduce it to a smaller set of data, right? And they do exactly, well, you know what they do. These functions also have like an analytic counterpart. So they have the same functionality, but only in an analytical way. So you know what they do. I'm not going to explain those. There's another group of functions out there that you might be familiar with or may have seen, but these will be your next best friends, like the row number or the ratio to report, the n value. Maybe unfamiliar right now, but they will be awesome when you start to get to know them. There's also a bunch of functions out there that are really specific statistical functions, like the cluster distance or the median. Well, median not bad, but the variance sample and the percentile ranking. So there are a lot out there that you might never use. So my advice to you, if you really need to do like statistical analysis report, make sure to have like a statistical analyst sitting right next to you, so they can interpret the numbers that you're producing with these functions. Okay, and see if you're on the right track and doing the right thing. One thing I forgot to mention, by the way, is if you have any questions or comments, or if you want to shout out something at me, feel free. You don't have to wait until the end. All right. Okay. So we have all these functions available, and this is the basic structure for the function. You have the function that might have 0 or more arguments, the over keyword, and the analytic clause. How can you tell an aggregate from an analytic function? By the over keyword. So every time you see the over keyword in your statement, that's the analytic function. Easy, right? So the analytic clause, it consists of several different parts as well. Okay, so the partitioning, the sorting, the window clause, they're all part of it. Okay, so let's take a look at a quick example and see how this thing works. I'm going to be using the emp table because most people are familiar, and I love that emp table as well. So we've got the ename job, ename depth node job salary, and the average salary over, and then you get 2 parentheses. So it's an analytic function because of the over keyword, exactly. You got the over keyword in there, so this is not an aggregate, it's the analytic counterpart. So this one, of course, adds a column to the result set, showing you the average salary for the whole set. And the biggest difference between an aggregate and the analytic function, like an aggregate would basically shrink down the result set, while this one returns the average on each row that it returns. Okay? Questions so far? Just keep trucking? Okay. So the first part of the analytic, of the analytic clause is the partitioning. Now this kind of partitioning has nothing to do with table partitioning. Okay, this just breaks up, it breaks up the result set into smaller parts. And the analytic function works on one of those smaller parts. It's very straightforward how they work, basically. We have the same query, the same analytic function in there, the average over whatever. because there are just the open close parentheses. It doesn't specify any partitioning clause in there. That means that the whole set that you get back is the partition that it works on. Okay, so there always will be a partition. It could be just a whole set. Okay. To break it up into smaller groups, you could partition it by depth in this case. So if you know emp, you know that it has departments 10, 20, and 30. So in this case, it will break it up into 3 smaller partitions, like one for 10, one for 20, one for 30, and it will do the average salary per partition. So now you see that the average salary is the same for each part of the result set, for each partition. So far, so good? Yeah? Okay. So I mentioned that result set a couple of times. So the result set is everything you get back from the database, all the data from the table or tables, and you work on that stuff. You could have your result set with one or multiple partitions in there, and the analytic function will work on each of these partitions. Okay, that's the easy part. The function is most of the time pretty easy to pick. The partition clause is very easy, partition by whatever. Now gets the tricky bit, and that's the window. And the window is what most of the time breaks up. Like then it gets a bit more difficult, but once you get kind of used to it, you'll enjoy it. So the window is always within a partition. Okay, you can never cross boundaries of a partition. And there are different flavors. So you have the blue one's result set, the orange one the partition, and the yellow one the window. What's so special about that window? Like the partition will never change. It's fixed, that's it. But the window can, as you go through your result set, it can grow with your current row. It's always going to be from the perspective of the current row you're looking at. Okay? So it could get bigger like that. You can also start with a big one and have it go smaller. Okay? You can even have a window which starts at a particular point and moves along with the current row. So you can have a sliding window as well. Okay? So the important part with the windows is it's always from the perspective of the current row. You can have a window start before your current row or after it. It could also be like your start above and even end above your current window or below. Okay. And to make things a little bit more complicated, there are 2 flavors of windows. You have row windows, where you say, okay, I want to offset of a number of rows, like, like rows 2 preceding, so before my current row, and 4 following, so after my current row. And you can also have a range window. The range window is most of the time variable. Okay, it's always going to be a numeric offset. The range is going to be 200 preceding, based on the value of my current row, and 175 following. So this works for numbers, but it also works for dates. The number of days ahead or days behind. The window, like the partition is easy because it says, well, partition by whatever. The window doesn't start like that. The window will always start with an order by, and that's just a regular order by with a couple of small exceptions that you can't use. Okay, so the window always starts with the order by. And then you can specify, I want rows or ranges, and I want it between unbounded preceding and so many following, and I want it to have, well, whatever. You can specify exactly how you want your window to be. The default, this one breaks up a lot of people, is range unbounded preceding. And I'll explain why this one's a bit. The ANSI committee, the standards committee, said it should be range unbounded preceding. So it's not Oracle's fault per se, it's the standards committee mission that made that up. So why does the window clause start with order by? say you want to do like a sum, right, to summarize different values. Normally the order by wouldn't matter, right? If you just sum 1 and 2 and 3, it would add up to 6. Once you introduce that order by, you say, okay, first I want to summarize 1, add to that the 2, add to that the 3. And your intermediate results will be different if the order was different. Does that make sense? One nodding and the rest falling off asleep, I guess. So the order by makes the difference. So the summary of the salary, we ordered by the e-name. We're dealing with an analytic function because of over. Thank you very much. So the over, we have an analytic function. We don't have a partition, so the whole thing is a partition. We order them by e-name, and the default window clause is range unbounded preceding. So if you look at the results in that last column there, one more remark, the e-name might not be deterministic. Yeah? In this case, all the names are unique, but they don't have to be. Okay? But we'll dive into that in a little bit more. So if you look at the first row over there, Adams, he's got a salary of 1,100. So you can see his salary and everything that was already in range, which is just his salary, 1,100. Go to the second row, add to that Alan's salary, and you get 2,700, and so on, and so on. Yeah. So it appears that we have a running total over there, right? Good. So it's that the e-name might not be deterministic, because we can have multiple with the same name, right? You can have more Fords or more Adams, whatever. One of the things why I like the M table, because you can do a lot of stuff with it, and they have some anomalies in there as well. If you look at Ford and Scott, they both have the same salary. Okay? So instead of ordering by the e-name, I'm going to order it by the salary. Yeah? So salary is sorted. The default window clause is range unbounded preceding. So if you look at Scott and Ford, you can see, yeah, I think you get it. They both have the same, in that running total, they both have the same value over there. So why is that? If this Scott is your current row, it will sort it by salary, yeah, and it will seize Ford salary as well. Yeah, going to the next line, Ford will sort it by salary ascending, and that one will see Scott's salary as well. So they both get the same value. So you might run your query like we did before and say, oh, running total, that's fine. But that range unbounded preceding clause trips you up the moment you go to production. When they say, well, that's not correct, because it's not a proper running total. So the way to do a proper running total is by being explicit about it. Order by salary, rows between unbounded preceding, and your current row. So everything you already had and your current row. So move that range window into a row window and be specific about it. And then the salaries will be what you kind of expect it to be. Questions so far? Lunch was good? You're all falling asleep? That's good. I appreciate that, so that's good. Okay. So what if you wanted to do like a running total per department? Yeah, exactly. You just introduce a partition. Partition by department number, keep everything the same, order by e-name, your rows unbounded preceding and current row, and you get a running total per department. 3 partitions, one for 10, one for 20, one for 30. If you look at Adams, that's the current row, that's his salary, added up to 1,100, and so on as you go through that partition. You can also see that the value of the sum of the salary, the running total, is reset for each partition. windows don't cross partitions. Okay. There. Now, in this case, in all the examples I've shown you so far, the order by of the window, I kept it the same with the final order by, the final predicate. Okay, so it's easy to visualize where the window starts, where it ends, but it doesn't have to be. Okay, your final predicate will do the final sorting, and it could be totally mess up everything. Well, not mess up, but the way you perceive it might be messed up. Okay, so there are a couple of functions that will help you visualize that window. Two pretty old ones and one relatively new one. The first value and the last value. In this case, the partitioning and the sorting is the same, and I'm only filtering on department 20 in this case. Otherwise, my slide would be even bigger than this one. Okay. So the first value basically points to the first value of your window. Okay. So if you look at that row on Scott, like the first value in the window is Adams. Okay, because the window starts at Adams and ends with Scott. And that's what the last value says as well. See? Starts at Adams and runs to Scott. Yeah? Oracle 11 introduced an nth value. So with first to last value, you could only say this is the first, that's the last. But what if you want to say I want the second from last, or the second from the first one? They introduced the nth value. I want to see the name, the second one from the top, basically, from the first. Looking at this data, all of the for the complete set, 4 is the second. Is the second one, right? So okay. So the question is, what if the order by, in this case it's ename, what if did ascending default? What if the order by was reversed? So if it was descending, um, it would partition it as normal, it would sort it as normal, and then you would get like the second one, still the second one. So it's going to be Scott. No, it's not going to be Scott, because your window expands as you go along. But there's a better way to do what you want to do, and that's by using the from last instead of from first. Okay, so you keep this one. You can see that it's expanding as well. You get the nth, the second one from the last, and because you have a like a growing window, you can see that the value changes as well. Okay. There are certain use cases for this nth value, like if you have a whole range of values and you want to cut off the highest and the lowest one and you get the average of that, it's more statistically correct, or so they tell me. So the nth value is very good for that one. Okay. Ah, there you go. Other questions besides that one? No? Okay. Ranking. One of the things that's always kind of, I like ranking as well. So they got 3 flavors of ranking functions in the analytic realm. One is row number, ranking, or rank, and the dense rank. And there are some subtle differences between the 3. Well, row number is comparable to row num, so it just assigns the numbers arbitrarily. Okay, it just says, oh, you're 1, you're 2, you're 3. Doesn't have to be really true though. Okay. The rank can skip values. Okay, while the dense rank doesn't skip values. Now the Oracle documentation says dense rank is an Olympic ranking, which is not true. It's the rank. I informed them it's not an Olympic ranking. I haven't heard back from them up to date, and I did that a couple of years ago. Okay, anywho, our M table filtered on department 20, and I sorted them salary descending. Why? Because Scott and Ford have the same salary. Okay. Using the row number function, I sorted them by salary descending in the window as well. Um, that would just basically say, okay, you're number one, like Scott is one, Ford is two, and so on. Even though they have like a split first place, right? Okay. So there's a function. The row number just says you're one, you're two, you're three, you're four, and so on. So it's comparable to row num in that aspect. Rank can skip values because they have the same salary. You have a split first place, and the next one down, that's rank. The next one down is 3. So it's 1, 1, 3, 4, and so on. Dense rank, that doesn't skip any values. So here you have the dense rank, same windowing clause and everything. And you have a 1, 1, 2, 3. Yeah. So altogether, row num, rank, dense rank, 1, 2, 3, 1, 1, 3, 4, 1, 1, 2, 3, and so on. So if someone asks you for, oh, I want to have a like, who is the most earning people in my company? I want the top 3. Now you can say, what do you mean, the top 3? Because your top 3 could have 4, 5, 6, if they're all share the same place, right? So there's a subtle difference between the 3 functions and the answers that you can provide for a certain question. So a top 3 per department. How do you do that? One of the things that that's a limitation of analytic functions is they cannot be used in the final predicate. They cannot be used in the where clause. Okay, so if you want to use them in a where clause, well, you can't, but you can push your query into an inline view or in a subquery factoring with a with clause. Use the analytic function over there, like rank in this case, and use the alias of that analytic function in the outer query and filter on the top 3. Okay, that's how it works. Because I use the rank function over there, you get like the 113 in that section going on. So what can you do with a ranking like that, or a ranking function? You can pivot your data. So instead of having going down the screen, you can also have going across the screen. And a trick to do that is to use a ranking function like row number or rank, and use the alias of that one to first of all filter your data, and second of all to use like a max decode function. So what happens there is, like, if you wouldn't do it like the max or the aggregate over there, you would still have like a big line over there, and because of the max it will squeeze everything together, and you get your data, instead of going down the screen for department 10, it goes across the screen. That's a nice trick. You can also use a real pivot. Oracle 11 introduced a pivot syntax. Whoops, it's on the other side. There's the pivot. I want to see the name for all of the top 3 of my ranking. Okay. Of course, the same result set. You get them going across the screen. Questions so far? Well, what happens to me a lot, well, not a lot, but what happens to me is that I kind of like insert the data again while I should have just done it once. So sometimes you want to get rid of all the duplicates. So say you inserted the data in the M table again, so you have 2 Adams, 2 Fords, and so on, and you want to get rid of all the duplicates. This is one way of doing it. There are several other ways, but I like this one. It's very simple. What I'm doing is I'm going to be using the row number. I'm going to partition them by name. So all the Adamses are in the same group or in the same partition. Fords, the Jones, and so on. They're all in the same group. And I'm going to use a ranking just to hand out numbers. Because I don't care which one to keep, my sorting is by null. I really don't care. Okay, as long as each one has a unique number within that partition. And then strike out everybody that has a ranking higher than 1. Yeah? So how do you go about that? You get your query with your ranking in there. You filter on where your row number is bigger than 1, or that alias of the analytic function. And we're going to select out the row ID and then delete from the table where the row ID is in this set. And that will delete all the duplicates. I like that trick. Okay, well, obviously. Okay. A common request is by some people like, how do you get to string your data together? Like, get like an output like that. Like for department 10, you get Clark, Miller, King, and they're comma separated. Yeah. That's always like a common request. How do you go about that? If you're an 8, and I assume nobody is on 8, you could write your own object type, like this one Tom Kite wrote, and you also need to implement a type body. The font size is on purpose. Okay. Then you would create your own function, like an aggregate function, using that object type. The aggregate function using that object type. And once you've done all those steps, object type body, as well as this aggregate function, you could use it in your statements, in your regular select. Pretty cool. If you are on a 9, and I assume nobody's on 9 either, they introduce, someone's laughing, so I hope you're not on 9, but okay. They introduced the sysconnect by path. It's part of the hierarchical, I hate that word, hierarchical queries, like the connect by stuff, start with connect by. The sysconnect by path just gives you a path from the start, from the root node. And using a trick, including that analytic function as well, you can get the same data out there as well. On 9, there was another way of doing it, and that was by exploiting XML features. Okay, create an XML element, create an aggregate of that, concatenate in the comma, get rid of that comma after you extracted the text, and then you get your comma delimited string together thing. Oracle 10 also had another way of doing it. You could create your own nested table type and use a cast collect to do that. It might look like a string together, but it's still what you call it, a nested table. Okay, so it's more or less string together. There was also a way, there's always one in every crowd that says, well, you can use WM underscore concat to do it, but that's an undocumented function. But it works, exactly. Use that function with your name, and there you go. But it works until you upgrade to 12. Because then they say any application which has been relying on that function will not work once upgraded to 12, since it has been removed. So no longer will it work. Yeah. So never use undocumented functions in that case. But 11 introduced a new function to do really what you want to do. Use the list egg with your name, your separator, and specify which group, what you want to be sorted, and then you have your string together thing. So that's the function you should be using. Search your source code for WM concat, replace it by the list egg, and you're good to go. So why am I mentioning this one? First of all, it's a really cool function, and it's finally available. Second of all, you can also use it as an analytic function by using the over and so on. And you get a result like that. Why you would want to get a result like that, I don't know, but you can, all right? 15 minutes to go, and I still have a lot to cover. Yeah. Any questions so far? Sure. Right. Okay. I thought you. Oh, that's a good thing. I like that. Just to repeat it out to, if I'm understanding you correctly, like to visualize the window, you could use that list egg function as well because you get all the values which are in that window. I like that. That's an awesome idea. I love it. It's better than your first and your last value to get out. I like it. Thank you very much. Um, one of the things you can do with analytic functions as well is you can access other rows, other values from other rows. And they got two functions to do that. One is the lead function, lead. I want to get the name next one down based on my partition and my sorting, of course. And what you get here is if you look at atoms, you can see Ford in the same line. And you can compare the two if you want. Like that Ford over there, that's the one, the next one down. But lead function is overloaded. You can pass in a second argument to say I don't want to see like the next one, but I want to see two down. And then you have the, well, you just say I want two down. So now all of a sudden Jones is shown on the same line as Adams. Okay. Now the question is, why is that one null? Or it could be that there's someone without a name, right? But they all could also be pointing outside the partition. So how do you distinguish between the two? There's a third argument for that lead function. I want to see the name offset by 2 rows, and if it's pointing outside the partition, show me this string. And now you can distinguish between your pointing outside of the partition and the null that could be in the next row. Okay, so that's the third argument. You get these. You can do the same trick, but instead of looking down the rows, you can also look up rows by using the lag function, and that's the same functionality. It just looks back one row. It also is overloaded with these things. Okay. Okay. So one of the tricks you can do with this pointing outside the partition thing is if you need to divide, like you have 3 rows and you need to divide like $100, it's going to be 33 and a third if you're just going to divide it. But then you're missing 1 cent, right? So what you could do is change this one to 34 and you're good to go. So how do you go about that? I want to have the next one null, 1 row, and the default is X. So the last row is marked with an X. Do some calculations and get the correct results. Round it at the last row. Okay. Analytic functions are awesome. They are awesome. I really love them. One thing you got to be careful of if you start using them and you start using them more and more and more. The minute you enter distinct an analytic function, you're probably doing it wrong. Because distinct will always shrink down the number of rows, while analytic functions don't. You might be looking into like a regular aggregate. So that's just a word of warning. There are some caveats. They cannot be used in the final predicate. Already said that. You always have to be careful of your null sorting. Okay. And if you have a lot of sorting going on, you use a lot of different analytic functions, you might bump into a lot of sorting. So it could have a performance impact. As a general rule of thumb, they outperform any other solution you might write. So first of all, the joins, the whereas, the group bys are processed. After that, they do the analytic functions and then your final predicate. Okay. So the first time that I encountered these functions, or at least the use for it, I was working for a telecom company, and one of my colleagues sitting behind me tapped me on the back. He said, "You like SQL, don't you?" I said, "Yeah." He said, "I got this awesome SQL. You really want to see this one." So I turned around and said, "Well, show me." And on the top of the screen, it said, in the comments, he said, "Find the most recent contract." And then he showed me a SQL. Yeah, that's what I said. Whoa. Whoa. Pretty, yeah. So I said, "Well, that's good. So what does it do?" That's obvious. Exactly. That's what he said. Find the most recent contract. Well, there, that's helpful. I said, "Well, what do you mean, the most recent contract?" He said, "Well, we have all these contracts of people, and if they if they have multiple contracts, I want to get the highest end date. And null still, well, it's still going on, right? Okay, sounds fair. What if you have someone who has two contracts and they both have the same end date? Which one is the most recent in that case? Or both are null? So, well, that's easy. And you look at the start date of the contract. And there shouldn't be any nulls, but it was from a non-relational source, so it could have. But they were filtered out in early state, so they shouldn't be there. But just in case. So end date, the highest one, highest start date. Now the question arises, what if you have two contracts with the same end date and the same start date? Yeah, well, they made an executive decision, let me put it that way. And they said, oh, just take the highest ID. We don't care. They're probably the same ones, so we just get the highest ID. So that was the requirement. And as I started turning around, looking at the query again, he said, oh yeah, and by the way, it does it per category of contract. So apparently there were different categories of contracts, and this query would find the most recent contract per category. So looking at the query again, somewhere down here, I think he compares the end dates and the start dates, or the IDs over there. I'm still having a hard time figuring out how this query works, to be honest. What I did notice is that he mentions the contract table in from clause and also in the where not exists part. So what he basically is doing, he gets like this table and starts comparing it. Like he gets one row where not exists and scans the whole thing. Goes to the second row, scans the whole thing, and so on and so on and so on. So, but because of his explanation, like how does this contract work, or how does this query work, he said per category. And that sounds like, oh, come on. Partition by, exactly. It sounds like partition by. So I figured, well, this must be a use case for analytic function. So I had this part, partition by, and then got me thinking, okay, which analytic function should I use? Like the lead or the lag so I can compare it, or the max, maybe the min. What if we start sorting by start date? What if we do this? I had a hard time. It was my first time writing analytic functions, so I had a hard time. I consider myself a typical developer, I think, because I drink a lot of coffee. So if you drink a lot of coffee, first of all, you have to get up a lot. First of all, to the coffee machine. Second of all, to the, well, you know. So while I was going to the, not to get coffee, let me put it that way, I was walking over there and I got away from my desk and I suddenly had the idea. Oh, it should be right here, right? I had this idea. I said, what if we would just rephrase that requirement? Instead of going from most recent contract, where I had a hard time finding that analytic function that I wanted to use, and rephrase it to the top one of contracts. Which analytic function would you use in that case? Top one. Yeah, exactly. Dense rank, one of the ranking functions, let me put it that way. Right? Just get me the top one. So here are the requirements. Highest end date, highest start date, ID, and per category. Well, the per category part is easy. You already had that one. Partition by category. We're going to sort it by end date. Nulls first, so the nulls one bubble up on top. This nulls first edition was added in Oracle 8. So if you haven't heard of it, no problem, but it's very useful. Highest start date. Start descending, nulls last. Just in case, even though they were already filled out. Highest ID, ID descending. Slap on a ranking function. You could use dense rank. I picked row number. And filter out on that alias to get me the top one. And I was so thrilled with this query. Can you believe that? I was like, oh, this is awesome. And he said, well, it looks good. Nice, like it. So you want to learn more about analytic functions? And then he asked me this question: what about performance? He said my query runs in while yours. Okay. So you can kind of get a feeling for how efficient your query is by looking at the statistics. I use SQL Plus a lot still. So I put on auto traits and you can get your statistics. If you look at your DB block gets, your consistent gets, you get a feel of how scalable your query is. So that's the original one with 165 gets and 0 block gets, and that one only had a 7 consistent gets. So I thought, okay, so let's bump up the volume of rows we have in the table. That one skyrocketed up. That one too, going from 7 to 31, so that's a pretty big leap. It's not as bad as that one. Bump up there again. Even more, go more recursive, even sorting to disk. So that's a lot of work. Okay. Why is nothing on that side? Well, after 3 hours, I broke off that query, while that one always finished around 8-9 seconds. So I was very pleased with myself, as you can imagine. So that was the moment when I fell in love with analytic functions. So, but looking back at the query, I thought to myself, well, are they really necessary in this case? Because you take like a whole pile of data and you basically reduce them to only like the first one per contract. And I just said, well, if you're going to use a whole lot of table and you're going to reduce them to a lot, should you be using analytic function? So were they really necessary? Because if you can do it in that part with your regular aggregate, you don't need to go to the analytic functions. So you can rewrite, get the same results by using a regular aggregates. So the max ID, the max start date, keep tens rank first, the same sort, and same for the end date as well. Group them by the category. So no, you don't need analytic functions in this case. Okay. Someone always asks, so how does this one perform as opposed to the analytic ones? This one's always slightly faster. Like the analytic function always finishes around 8-9 seconds. This one always goes to 7 and 8. So it's still a bit better. Oh. So there are always other options to explore. See if you have enough time and want to play around a bit more, explore other options. Okay? Because there are always multiple ways to solve a certain requirement. Okay? Very important, test with representative data. Not only like the quality of the data, but also with the volume of data. Okay. Comment your code. Don't just say find the most recent contract, because there's a lot more to it than just that. My opinion, no, it's not my opinion, but I do share this thought of Tom Kite. It is the best thing since the select statement. I love them. I think everybody should be using them. I think they should be used a lot more. So if you haven't, you go out and explore. The images I use in this presentation aren't mine, so the credentials go to them. There's still 1 minute and 19 seconds left if someone has any questions. Everybody fell asleep? It's all clear? Oh, there's a question here on the front. I was hoping everything is clear so there are no questions.
There is one problem, this list aggregate function, because it can only 4,000 bytes, and after that it raises an error.
Well,
so maybe Oracle will do CLOP counterpart for that function, or maybe done in 12.
Yeah, but in the current release of Oracle, that's a restriction of the list aggregate. True. There are some people that wrote blogs about them, how to get around that. I don't work for Oracle, so I would like to say, oh, it's on their backlog and they're going to fix that. But I don't know. I'm just hoping that they will. But yeah, true.
you of course can do it with XML function. Flop to make flop basically.
Yeah, yes, you can convert it to XML, but it depends on the version of the database. If you're on 12, you can have var charts which are 32K. So that will be that will be your next limit up, as opposed to 4,000 characters. Yes, you can. Can you define your own aggregate function in Oracle? Yes, you can. Yeah. 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 Just create your own list aggregate with a CLOP. Yeah. Yeah. It's a challenge, I think, but all right. So time's up. If you have any other questions, I'll be around for the rest of the day. I'm going to be here tomorrow as well. So thank you very much.